All right, we are back and welcome back to our programming concept series. Today we are going to talk about adapter pattern, one of the most practical and useful structural design patterns. This pattern is about making two incompatible systems work together without touching their original code. So, object and definition. The adapter patterns allows object with incompatible interfaces to collaborate. In other words, it translates the interface of one class into another that the client expects. You can think of it as a translator between two components that normally you didn't communicate. Let's use this analogy. Imagine you have a laptop with a USB-C port, but your flash drive only has a USB-C-A connector. So you use a small adapter, plug the flash drive into the adapter, and now it fits perfectly into your laptop. That's exactly what the adapter pattern does in software. It adapts an existing interface to make it compatible with another system. So let's code. No, it's not code because it's already done here. But let's check this. We have our notifier here, just send. And then we have, this is just a didactic sample. So let's talk about this. Now we have a legacy SMS client. So this is working before, and we don't want to touch that. But in our system, we need to adapt that. So we have this legacy system client, and this is the interface our app understand. Like, let's get back here. So this is the interface that our app understand. And we have this legacy SMS client, and our app doesn't understand that. So different method names, different parameters. So to use it without rewriting the legacy code, we create an adapter. And now we have the SMS adapter. So the SMS adapter will receive the legacy with a constructor. So different, like I say, different method names, different parameters. So to use it without rewriting the legacy code, we create an adapter. And we will we will use the send, like the iNotifier, and we are sending here, send SMS with the legacy. And if it's okay, we receive the okay, we'll send a message here. So let's check this. I have the program here. So I just say, I create this demo. So this demo, I receive a notifier, and I'm creating the SMS adapter, and in its constructor, I have the SMS client.
Aqui está o lembrete de
Oh, sorry.
ligar Everaldo.
So let's run. Uh, all right, I have this. So look what's happening here. The legacy SMS client sent the SMS, and the SMS adapter use this guy and say SMS sent successfully, and it's done. Like I did, like I put here, it's done. Now the adapter implements the interface our system expects and internally translate the call for the legacy API. So now our app can send SMS messages to the legacy service without changing any of its codes. That's the essence of the adapter pattern. Make old code work in new environment. Now let's talk about the real world example. Uh, let's change here and let's close everything. So let's go back. In real life, adapters are everywhere, especially when you integrate third-party APIs or SDKs. Let's say we have two payments gateway. We can talk about Stripe or PayPal. Each one has its own interface, but we want a single one, unified API in our system. So let's build this interface. So I have the payment gateway. I don't want to know which one it is. So it's a payment gateway. And I have two and I have a DTO here with the payment request and the payment result. It's just a DTO, doesn't matter. So all right. And we have this the Stripe client is our SDK. So we have the Stripe client. So what the Stripe client does? So we have this interface here. This client, this Stripe client is just pay a sync. And I have the same in other. You could use many of them, but you can check the PayPal client. Make payment async. Oh, it's something in Portuguese here. I'll remove. So make payment async. Can you see? It's not even the same name. So, but it's two separated SDK. So we have this SDK charge, the PayPal SDK charging, and the Stripe SDK charging here. Uh, the Stripe SDK might look something like this, and the PayPal like this. So the adapters. Now we will build our adapters, one for each SDK, so that both conform our iPayment gateway interface. So now we have a PayPal adapter, and like the previous one, in the constructor, I will receive the client, the other SDK, doesn't matter. And now I'm following the payment gateway that we have charge async. So with the client, I'm using the PayPal. I make the payment with the requisition here. And I'm saying the PayPal adapter, it's okay. And it's used some kind of time here. And if I have a problem, I have this exception. And I will do the same with the Stripe adapter. At the constructor, I will use the Stripe client. And I'm running the PayPal async. And that's it. So now we build our parameters for each one, both confirm our payment. And we have a PayPal adapter and the Stripe adapter. Now let's see the usage. I can check here in my I have the checkout. All right. So in this checkout, I have the payment gateway with the Stripe adapter, but I'm not using this checkout. So let's check the program. So I have a requisition here, and I can use two kind of way to pay that. So even though those two of them are payment gateways, but one I'm using the Stripe adapter with the Stripe client, it's just an SDK. And here I'm using the PayPal adapter with the new PayPal, with the PayPal client that is a SDK. And I'm just saying that Stripe is use charge sync. And if I have a problem, if something happened, I will have all the messages here. And let's see this running. All right, so uh, here the first one is a Stripe. So the SDK is charging. Then I'm using the adapter and sending other messages. And the client just say that I have successful here, some sex here. And the PayPal SDK and the PayPal adapter like doing the same. And look how important is that, because now we can use some tests here. So I have the PayPal adapter. So fine, let's take a look in how we can test our adapters. We don't want to call real payment APIs. So we will mock them, use NSubstitute. So here I have the payment, and I have the payment client. The payment client, remember that this is just as SDK, and I have a PayPal, and I'm using the make payment async, returning this. I'm just mocking something here. And when I create the PayPal adapter, I'm sending this mock behavior here. And when I have this PayPal adapter and I use charge async, what is expected? Suseful, equal, and error new. And I can do the this is the PayPal, and I can do the same with the Stripe and substitute. So here I'm configuring the return and doing the same. So why this matters? The adapter pattern is extremely valuable in integration heavy systems. It's allow your code base to remain clean, even when connecting to multiple third-party APIs or legacy modules. Instead of polluting your domain with external details, you translate those systems to small and isolated adapters. In a nutshell, adapter is about translation. It doesn't add new behavior like Decorator, and it doesn't notify multiple listeners like Observer. It simply makes incompatible interface compatible, clean, safely, and without changing existing code. And that's it. That is the adapter pattern. In the next video, we'll keep exploring structural patterns that help build maintainable and scalable software architectures in .NET. If you find this useful, check out our full code and unit tests at GitHub repository linked below, and see you guys.